This is Max Gravitt at Digital Scarcity. The purpose of this video is to walk through a tutorial on how to develop a dApp on the EOS blockchain. This tutorial will be broken into three parts. The first part will be development of the smart contract. The second part, development of the web application. And the third part is development of the mobile app. This video will be just for part one, and we'll break it into 5 steps to develop our smart contract. The first step will be to define the scope of the smart contract, essentially what problem are we trying to solve. We'll define the actions of the smart contract. We'll define for each one of those actions what are the pre and the post conditions that need to be true for those actions to be successful. Then we'll identify from there what data model is required to support those pre and post conditions. And then finally, we'll get to build and deployment. This will all make more sense as we go through it. And then there'll be subsequent videos that walk through part 2 and part 3. So for this tutorial, the scenario, very simple scenario that I've identified here, we're going to build a marketplace for renting equipment. Equipment owners will be able to rent their equipment, and those in need of that equipment will be able to find that equipment that they can pay tokens to rent that equipment for some amount of time. One thing I also always do in the definition step of a dApp is work to identify the tokenomics. For this particular dApp, we're not going to be inventing any new tokens. But we're going to allow the equipment owner to specify any token that they wish in terms of their hourly rate. So they could specify their rate in the native EOS token, or they could specify some other token, someone that they've been airdropped, or something else that they purchased on an exchange, or maybe just a token that they're interested in. They could list their equipment for rent in order to receive that token. All right, so step 2 is defining what the actions will be. And these steps will translate directly into our actual code development, which we'll do in the final step. But really find that this process helps me, wrap my head around exactly what we're trying to do and how to organize our smart contract. So step 2 is to define our actions. And our roles. So there'll be 2 roles for this dApp, the equipment owner and the equipment renter. The equipment owner will have 2 different actions. Adding equipment, of course, that's just listing the equipment for rent. Evicting rentals once they've expired, once the rental period has expired and if the equipment has not been returned. The renter will be able to deposit funds into the smart contract so that they can rent equipment. And of course, they'll be able to return the equipment after their rental period is complete. So the next step 3, that I typically define is for each of those actions, would define the preconditions that must be true and then the post conditions that must be true after that action completes. So for the precondition of adding equipment, of course, the equipment must not already exist. The hourly rate will be a required attribute when the owner is listing their equipment for rent. And then for the post conditions, the equipment will be added and it'll be listed for rent. It'll be available for rent. For evicting of rentals, the preconditions that must be true is that the rental period must be expired. And the post condition is that rental record is erased. For depositing of funds, no preconditions. And then the post condition for depositing funds is that the user's balance has increased accordingly. And all this will make a lot more sense when we get into the smart contract. And then I have similar pre and post conditions for renting of equipment and returning that equipment. The next step is to identify what data is required to be stored, persisted inside of our smart contract in order to enable these pre and post conditions. So here you'll see each of the attributes that are required for those pre and post conditions. The owner of the equipment name, description, the hourly rate. We're going to need to save a user's token balance, keep track of all of the active rentals and so forth. Here's that information just in an entity relationship diagram. It's a little easier to read, and this will help us translate it into a smart contract. So we're going to have 3 different tables in our smart contract. One is sort of our equipment master data, if you will. It'll keep track of the name, the description, the owner, the token contract, and the asset for rental purposes. We're going to have a table of all the active rentals, and there we'll have the renter, the person that is currently renting that equipment, when that equipment was initially rented, when it was last updated, and the expiration date. The last updated timestamp will be for if they add additional rent in when it's already been rented. All right, and finally, the balances table is something that just comes in the template contract that I'll be using. And it just is going to keep track of all the tokens that have been deposited for all users into this contract. These are the steps that I typically take in development. Of course, it's very much an iterative process, but just to give you an idea, I usually start from a template that is a public repo. This is the link for it. We'll talk about that in just a second. Then I work on the data model and the action templates, which exist in the smart contract header file. Then I implement the actions in the C++ file, the implementation file. And then I put together a script file, which essentially just walks through here all the sequence of how the action should be invoked. Then I deploy and test them locally. When you deploy and test locally, if you don't have it turned on, you don't have to worry about staking for resources, which makes testing your business logic in your smart contract much easier. Once you get that nailed down, then I deploy to a test net, either the Jungle or the Kylin test net. When you use those, you deploy resources. You get a little bit more of a real world feel for how your contract will operate, and then finally deploy to mainnet. Here we're just going to go up through deploying and testing locally, and then I'll work on another video for deploying and testing to Jungle or to the Kylin testnet. So let me talk about this template that I have, or that's available for starting out your smart contract. So it contains a few different things that I've found that are needed with each project. So it has a Docker file and a Docker Compose YAML file that lets you work up some containers to run Node.eos and Kios and EOSIO CPP, which reminds me, that's one note that I want to clarify for this example. It does not use the new EOSIO.cdt, the contract development toolkit. I've not been as fast as I would have liked to migrate all my contracts over to that standard. So I'll publish a video that once these contracts have been migrated to the new standard. But for now, everything absolutely works and everything's 100% compatible with the old. So anyway, it contains the Docker files needed. It contains a script to unlock the wallet. Where you're able to just plug in your wallet password, your Kios wallet password, and then it includes a template smart contract. It includes functionality as an example table for saving data, a multi-index table. It has an example action. It also has all the scaffolding for accepting deposits into your smart contract, managing user balances, and paying tokens to individuals. These are all things that I found that for any new smart contract or dApp that I'm developing, typically always involves these components. So for that reason, I've added them to my template. All right, so the template is located at this location here. So let's copy that. It's EOS template. So what we'll do is just clone this repo to get started. All right, so let's take a look at what we have. I've included in the template a copy of EOSIO.token, which is developed by Block 1. It's the standard contract for tokens. It's not deployed by default into your local Docker Node.EOS instance. So for that reason, if you're going to be doing token transactions during test, I include a copy of that smart contract in the template. Just makes it easier. And then I've created this this class to get started, or this contract to get started, B-plate for boilerplate. And we'll take a look in here. Includes just some of the stuff that I find I always need. Pay token, so anytime you need to pay token, you're able to just pass in the token contract from to the token amount in the memo, and it's able to pay that. Balance table, it's able to keep track of the balances for users that are depositing funds into this contract. And then I just have one get started action called my action. Now let's take a look at the C++ file. The implementation file here. So this is all boilerplate to handle deposits into the contract. So you'll see that when a transfer occurs to this contract, this transfer received function will be called. And this is where I add the balance of the sender into the balance table of this contract. All right, so let's rework a little bit of this in order to move it up to our, call it our equipment rental scenario. So we'll just rename much of this. I'll delete the ABI, so we're going to be regenerating that. Same with the WASM files. Equipment rental. The README here gives you some of the CLEOS and EOSIO CPP commands that we're going to need to alias. Let's see. Anything else we need to change? Well, what I'll do is I'll overwrite this template with my actual unlock file. And let's take a quick look at the Docker file, the Docker compose file. So it's pulling in the latest version of Node.EOS, and there'll be a container for KeosD and Node.EOS and Mongo as well. And there are instructions for this inside of the repo for the equipment rental the link of which you could find on the front page of the slides, and I'll also put it in the video description. Let's get our Docker instances up and running, and then we can start development. I gotta rename my container name here is EOS template, so I need to change something in my unlock file. I'm gonna pause the recording while I do that. All right, so now the container should be the right one, and here I've unlocked my wallet. Let me also go ahead and alias Kleos, which if you go to the README file in my template, you'll see that the commands to EOS, or to template EOS, or Kleos rather. And here I should be able to do Kleos get info, and there we go. It's probably a little too big. And I can also alias EOSIO CPP. Okay, so at this point we have Docker set up. We have our template that we've created, or that we've cloned from GitHub. We've renamed the smart contract. Now we have to go into the contract and start making some changes. The first thing we're going to need to do is replace bplate, which was part of our template, with equipment rental. So I'm just going to do a Control H, bplate equipment rental, replace all those. And I'm going to do the same thing in the CPP file. Okay, and as I mentioned before, the first step that I typically do is pull in is work on the structs, the data model. What am I going to be saving? And that is in the HPP file. So I'm not going to type it all out. I'm going to copy it from our equipment rental repo, which again, the link will be in the description of the video, as well as the slides. So we'll go into the contracts, we'll look at equipment rental. Let's go into the HPP file. And this is what we'll be building, but we'll kind of build this out step by step. So as I mentioned, there are going to be 3 structs, one for balance. This is actually already included in the template, so we don't have to worry about this one. Equipment, which is going to be for listing out our equipment master data, if you will. And then finally, our rental table. So we'll just copy this. And we'll paste it in here. We also mentioned we're going to have those 5 actions that were on our slides. Let's go back to look at those just as a reminder. Here, add equipment, evict rentals, deposit funds, rent equipment, and return equipment. So let's copy those from our template. I'm sorry, from our repo that has the implementation completed. So you'll see there's new equipment, and this is where I'm just passing in the attributes of that equipment for name, description, owner, token contract, and hourly rate. Remove equipment just deletes that piece of equipment from the list of available equipment. Rent, this is the action that actually adds the rental record to the table and sends the payment to the owner of the equipment. Evict, return equipment. So here are the 5 actions. We will copy these. and we will override my action, or overwrite it. Okay. So the other thing that we're going to need to do down here is we're going to make sure we list all of our actions in the EOSIO underscore ABI macro call. So get the names right, we'll just go back here and copy it. Actually, it must be in the CPP file. That's fine. We'll remove it from our HPP file here. And it can go in either the HPP or the CPP file. That's fine. Actually, you know what? It won't be needed because in this example, we are receiving funds directly into the contract, and we call that method or that macro, the EOSIO ABI macro, we call from the apply function here, right here. So this is where it will go. So while we're thinking about that, let's go ahead and update the apply function to include our actions. So here, this is where we list each one. This is what tells EOS about our actions, so it knows to execute those as they're invoked. New equipment, remove equipment, rent, evict, and return equipment. So if you leave these out, you will not get an error, but when you execute those actions, just nothing will happen. So there's no error handling around calling an action that doesn't exist in this list. It just does not. The action comes back with no errors, and it says nothing happened. So just as a heads up, that make sure you have this list of actions correct. All right. Let's come back here. We'll paste that. All right. Now what I'll do is import or paste in the implementation of all of the actions, those 5 actions. I'm going to grab and paste them in. Now, a full explanation of all the details inside of these actions is beyond the scope of this video, just because I wanted to keep it somewhat short, but I'll do just a very quick tour of what each of those actions is doing. So we'll, again, overwrite my action, which came with the template. And here are the 5 actions. Again, new equipment, remove equipment, rent, evict, and return equipment. So I'll just do a very quick tour here. For new equipment, again, we're taking those 5 parameters that are required, and we're doing an in place into the table. So just as like an insert row into that table, and that's all that it does. It does for the primary key, it assigns an integer to equipment ID, and it's just an incrementing integer calculated by EOS. So it looks at all the existing records, the IDs that are used, and it just increments to find the next one. Remove ID or remove equipment just takes the equipment ID, and then it deletes that record out of the table. Rent is what actually does the most of the business logic here. You pass in the equipment ID to be rented, the renter who wants to rent the equipment, and their payment. And so it finds the equipment in the equipment table. It looks at the balance to make sure that the user has the funds available, the renter has the funds available. Then it opens up the rental table. It looks for that equipment ID. If it cannot find it, it adds that rental record to the table. Again, it's another in place, and it just resets the expiration based on the hourly rate and based off the funds that are available. to sort of give the renter more time, so to speak. It restarts the clock on the rent, restarts the last updated. And then if it's already rented, what we do is we just modify the record to add more time, to update the expiration to add more time. Then we call pay token, which again was in our template, and this is what pays the rent to the owner of that equipment. And we erase the balance because we've spent all the money by sending it to the landlord, the owner of the equipment, and increasing the rent time for the renter. So we must erase it from our balances table. So evict, this is where it handles our preconditions here. It makes sure that rental period is expired. So if it was not yet expired, the equipment owner would not be able to evict. So it makes sure that expiration is in the past, and if it's in the past, then the action will proceed and it can be evicted. But if it's not in the past, the renter is still obligated to have that equipment, and so the owner cannot evict. You can return the equipment, and this just returns the equipment by erasing that record in the rental table. And that's it. Those are our 5 actions. Okay, so just back to our steps for build and deploy. Let's check back in on where we are. We started from EOS template. We deployed that or cloned that, and we've made modifications to turn that into our equipment rental contract. We created our structs in the HPP file. The 3 structs that we needed, balances was already there, but we added in the rental struct and the equipment struct. We put our 5 action templates in the header file, and then we implemented each one of those actions in our C++ file. So our next step is to write out our script file that will contain all of the invocation steps. So here I will create a new file, and I'll call it the same name as the contract, equip rental, and I'll use a .sh extension. And to be honest, I don't really run this file as a script itself, but the .sh extension helps apply all of the right syntax highlighting to the file, just makes it a little bit easier to read. It's more of just here are my notes and a reminder, a place to copy and paste all the commands that we'll be issuing to Kleos. Okay, so let's head out to our equipment rental repository, and let's find the .sh file. And here are all of our commands. So what I'm going to do is just copy. Actually, let me just get the raw, and I'll copy all of this, and then we'll walk through as we execute each one. Paste that in. Okay, so it begins with our compilation steps. Again, it's mostly here just so that it gives me a place where I can come and copy and paste and issue all of these commands to the console. Okay, so I think we're going to need to change this a little bit. Let's see, we don't have a contracts folder. So let's see if this works. So this is EOSIO CPP. It creates the ABI file and it creates the WASM file that we need. So now, if we take a look, we have the ABI file, the WASM file, and the WASP file. Those are the 3 that we need to deploy our contract. And again, we're doing this all locally. Kleos get info, we're up and running, and we have our Kleos is aliased to our container, and EOSIO CPP is also aliased to our container. Again, these commands, the alias commands, are in the README file of the template. Okay, so we've compiled the contract. That's great. I'm surprised that worked on the first time. We will now create the accounts. Oh, our wallet is locked. Okay, we're creating these 5 accounts that we need. Equipment rental for the contract owner, a couple renters, and a token. Oh, that's the other thing that we need. We have that already, actually. We have that token here, and that is already compiled. So you'll see that we'll deploy it so that we can use a token in the smart contract. But once we deploy to mainnet, we're going to use the tokens that are already there. So we're not going to actually need that in production. That's just for testing. Okay, we also need to update auth. This essentially just is giving permission to the code of the contract to transfer tokens on behalf of itself. Full explanation is beyond the scope of this video. Okay, so that all worked. Now let's deploy the contracts. Again, I don't have this contracts folder in this example. Perfect. Okay, we're going to use, just for testing, we're going to create this token called the rent token, and we're going to issue some of that to both of our renters. So let's copy this. Great. Okay, and now we're going to create some example items, equipment items. So these have the 5 attributes that are required: the name, the description, the owner, the token contract. Again, we just call it token here, but again, the owner is the person that's going to be submitting this transaction, and they can decide the token contract and the denomination and the amount for what they require to rent their equipment. So we'll just do the first one to make sure that works. Great. So one of the things we can do is just check to make sure that that worked by checking the table. Perfect. That's great. That shows up there. Now let's create our other 2. Perfect. Okay, so now we have our equipment created, we have our token issued, we have our accounts created. What we'll do now is transfer tokens from the renter to the contract. Well, we'll just transfer 1 rent token. Great, that worked. So we can now check to make sure that that's showing in our balances table. Perfect. So Kleos get table, equipment rental, the name of the account for whose balance we're looking to retrieve, and then the balances table. It tells us this guy has 1 rent deposited into our contract. And again, we already looked at our equipment, and we can look at should be no tokens there. Okay, so now let's go ahead and test equipment rental. So we'll first take a look at our rental table. Okay, nothing has been rented so far. So we're going to rent the equipment ID for number 1, which is going to map to this table saw. And it is 1 rent per hour. And I'm going to just pay in the 0.05. So that's going to give me just 5% of 1 hour. Just a couple minutes. All right. Oh, great. I got an error, so I can work through how to see errors. So what I'll do is create a new tab, and I will load up the Docker log. So I'm going to look at Docker logs for our EOS template Node-EOS container. This brings up all of our block production history. And what I'll do is go find the error. Okay, great. So the failure is that no balance required for symbol found. All right, let's take a look. Okay, let's pick back up. I figured out there's a little issue with the test script there, but it'll be fixed in the repo. And we're back to the scenario where the equipment is listed. Let's just take a look at the equipment. We have our 3 items that are available for rent. Our renter has 1 rent token as a balance. And just to show you, in the token contract for this owner, they do not have a balance. So they have not received any of the rent token at this time. So what we'll do is we will call the rent action. If I can get the copy, there we go. And so there we go. So what happened was we should have added to the rental table. So let's take a look at that. Perfect. So here we have our renter, and the equipment ID of 0, which was that top item, the riding lawnmower, has been rented to renter. And these are the timestamps for when it was rented out, as well as the expiration, the rental expiration. And let's also check the balance of the owner. And so the 1 rent that was paid to the smart contract and then was used in the rent action was paid to the equipment owner. So now let's try to evict. Let's see if I tried to evict now. Let me use the right. I get an error. Perfect. That's exactly what I was expecting, because the rent has not expired yet. So we get an error, and the token was transferred. And let's go ahead and return the equipment. Oops. The right equipment ID, and the renter can then return the equipment. And here we will go back and check the rentals table, and it's been erased. So in just a final review, let's take a look at what we've done. We started with the template. We put our data model in the HPP file. We put our action templates into the HPP file. We implemented those actions in our C++ file. Then we wrote that .sh file. Again, not so much as a script that was going to be run, but as a place where I issue all of my commands so that they're easy to copy and paste from. And that helps if you have a bug or you get your contract to a state where you want to just start back over. All you have to do, and I'll just show as a quick example, you can bring down the containers, bring up the containers, and unlock your wallet, and all of a sudden you're back to a clean chain Every time these containers restart, they delete all blocks, so that every time I start them up, I get a brand new blockchain with no accounts created. And then I can very easily just come back into the SH file. And let's say I wanted to get back to the step where I was right here, right before the rent. And all I can do is just copy all of those statements, come back to the console, open paren, paste it in, close paren. Let's see. I didn't copy from up high enough. Sorry about that. So copy from all the way up here, and we'll get back to this level. And here it'll just crank through all of those commands. It'll recompile your contract. It'll redeploy your contract. It'll recreate all the accounts, and get your contract back to a state to where I was doing that troubleshooting before. Let's see. Great. So my next step, we've deployed and tested locally. My next step, I'm not going to do it in this video. I'll do it in a subsequent video. I will be deploying this to the testnet, either Jungle or Kylin, do some additional testing, and then I would deploy it to mainnet. And then back at the bigger picture, this again is just part one of developing a DApp on EOS. The next step, future videos, will be developing a web application that allows these equipment owners to list equipment and renters to rent that equipment. And then finally, of course, a mobile app, which would be compatible with both iOS as well as Android, where we could have equipment owners, listing their equipment, listing photos of their equipment, and allowing renters to come in and issue tokens in order to rent that equipment. This is Max Gravett at Digital Scarcity. I hope it's been helpful.